Okay, in the last video we looked at Euler paths and Euler circuits, and the idea was that you had to try to make it through a graph using a simple path and getting every edge, and we saw that wasn't possible for a graph like this, but we did see examples where it worked. Hamilton paths and circuits are similar, but the idea is that you have to go through every vertex exactly once. Okay, so for a Hamilton path or a Hamilton circuit, it's a simple path or a simple circuit. That means you can't retrace edges, and you have to go through every vertex exactly once. Now, we're going to do this by exploration here. In this graph G, you can hopefully see there's a nice simple path here from A to H, right? From A to B to C to E to D to F to G to H. All right, this would be a Hamilton path. Okay, we used every vertex. We didn't retrace our steps at all, and we went through every vertex exactly once. Now, if we tried to do a Hamilton circuit, we would have a little bit of a problem. Okay, just made another copy of the graph down here. In a case like this, right, to have a Hamilton circuit, right, we'd have to be able to get back. Sorry, I spelled that wrong. Hamilton circuit. Right? No matter where we start, we'd have to be able to get back to where we started. And you can tell, first of all, by this bridge here, that once you cross it, you're never going to be able to get back to the other side. Right, no matter what we do, once we cross this bridge, there's not going to be any way to get back without retracing our steps. We're going to have to go through both of these vertices twice. So we're going to have to just sort of explain that it's not possible, but there's no definitive tests for Hamilton paths and Hamilton circuits the same way there are for Euler paths and Euler circuits. That makes this a much more complicated problem. It makes it a little bit less confident that you have the right answer. Certainly if you find one, you're good to go. But just because you can't find a Hamilton path or circuit doesn't necessarily mean there isn't one. There are a few conditions that do guarantee there is a Hamilton circuit, but lacking those conditions doesn't mean there is not. So they're not very clear-cut definitive tests. Now, if we look at a graph like H over here and we want to find a Hamilton path, right, you could pretty much start at any vertex, and it shouldn't be too hard to make a Hamilton path, right? Again, we went through every vertex. I didn't actually label these here, but it's not too complicated. There's actually two there, right? But you could see the Hamilton paths. Okay. Now for Hamilton circuit, right, we could try the same basic thing. And if you notice in this last graph, right, if I just continued right here, that would complete the Hamilton circuit. So what I can do is I can try that again. I can go from the same exact route. Oh, but right here I have a problem, huh? I can't go back that way because I'd be going through that vertex again. How do you think we could fix that problem? Right? Well, what if we just started right here and then jumped on the path we were before? Right. Oh, now we have a problem over here that we're going to hit that vertex again. Okay. So you can see there's going to be a little bit of trial and error, and it's not always going to work out the way we think it is. We're going to have to do a little bit of exploration. Let's try going this way. Right, and there we have it. Okay, so there is a Hamilton circuit, right? And you have to be a little bit careful that just because you try something that doesn't work, you don't say, well, it can't be done. You have to go through a lot of different scenarios, and in theory, you'd have to go through every possible scenario, start at every single vertex, and follow every single path possible, and show that it can't work until you can be definitive that there's no Hamilton circuit. Okay. Now, sometimes you can make an argument in a case like this that once you cross this bridge, there's not going to be any way to get back from it. But when you have problems like this, it's really just a matter of exploration and trial and error. Okay, so don't be discouraged if you don't find it right away. Just try starting at a different point and see if you can make your way there.